Hey guys, Jake here, coming at you with another math lesson today. Here's the problem I'm going to be showing you how to do today. If you haven't already checked out my other linear approximation or linearization videos, I'll put a link up here. You can go check out yesterday's to, kind of get a little bit of an introduction to this. But what we're going to be doing today is using linear approximation or linearization to estimate the square root of 24. So obviously 24 is not a perfect square, so the square root of 24 is going to give us, some infinite decimal. But what we're going to be able to do is use linear approximation to get an estimate for that value. So thinking back to the linearization videos that I've posted, what you want to kind of think about with a problem like this is what information we need to apply linearization or linear approximation to a specific function. So what you want to think about is we need basically a function to apply it to. So we're going to need some sort of f of x. And we also are going to need some a value that we are looking at that is near the value that we're trying to estimate. So since we're dealing with the square root of 24, the kind of most obvious choice for our f of x would just be the square root of x. Because what we could think about is if this is our function, we would be trying to find this square root of 24 would be the same as f of 24, right? If we just plug 24 into our function f, that would give us the square root of 24. So we're trying to estimate f of 24, but what we want to think about is what a value is near 24 that we could use as kind of our focus point of our linear approximation. So with that, you usually want to pick some sort of value that is pretty easy to plug into your function. And the closest value to 24 that would be easy would be 25, because if we take the square root of 25, that just gives us 5. That gives us a nice whole number that we can use to estimate just one over from 25. So this would be kind of the most logical pick for our a, because it gives us a nice integer number when we plug that into our function. So basically what we're doing is we are trying to find our linear approximation of our function f of x, which is the square root of x, at around the point a equals 25. So with those two pieces of information, all we really need to do is plug this into our linearization formula, which is L of x equals f of a plus f prime of a times x minus a. All right, so we already have our f of x, which we could, pretty easily just plug our a into to get f of a. We already know our a is 25, so this x minus a is going to be pretty easy. But we do need to find f prime of a. So first thing we'll want to do is figure out what f prime of x is. And remember, square root of x is the same as x to the 1/2 power. So taking the derivative of x to the 1/2, we could just use power rule, bring the 1/2 down in front, keep our x there, and then lower the power by 1. 1/2 minus 1 is negative 1/2. So that's our f prime of x. And again, keeping in mind that raising something to a negative power is the same as moving it down to the denominator, and 1/2 is the same as square root. So this is the same as 1 over 2 times the square root of x. So now we want to start plugging in these different pieces into our linearization formula. So f of a is just going to be plugging 25 into our function f, which is just going to be square root of 25, which is 5. So we'll just replace that with a 5. And then we're going to get f prime of a, which is just plugging our a, 25, into f prime. So doing that, we'll get the square root of 25, which is 5, times 2 is 10. So we're just going to get 1 over 10. So f prime of a is going to be 1 over 10. And then x is going to stay as x, a is going to be 25. So we'll just put a 25 in there. Okay, now we can kind of simplify this. Distributing our 1/10 in there is going to give us 1/10 x minus 2.5, and then we do have a plus 5 out here. So plus 5 minus 2.5. That's just going to simplify to plus 2.5. So this is our linearization formula, which now we need to use this to estimate the square root of 24. So all we're doing is, instead of finding f of 24, we want to use our linear approximation and plug 24 in there. So what we really want to find is our linearization of 24, because this is a lot easier to work with than our original f was. So doing that, all we really need to do is replace our x with 24, and 1/10 times 24 is 2.4, and then 2.4 plus 2.5 is going to give us 4.9. So that is our estimate of square root of 24 using our linearization that we found for that function.